Okay, reference angles. First, let's learn what a reference angle is, and then we'll learn what are they used for. So, a reference angle, simply put, in any quadrant, is a distance to the x-axis. So let's go through a second quadrant angle, a third quadrant angle, and a fourth quadrant angle, and note the reference angles. So, if we have an angle of rotation in standard position in the second quadrant, let's call this angle of rotation 120 degrees. The reference angle is simply your distance from the x-axis. Now, in order to calculate a reference angle, just know that the x-axis is 180 degrees. You have to think, am I before 180 or am I after 180? In this case, we're before 180 and we're going 120 around, which means we would have 60 remaining to get to the x-axis. Therefore, our reference angle for 120 degrees is 60 degrees because that's how far we are from the x-axis. Now, this would indicate a negative angle of rotation because it's going clockwise, but reference angles are a distance, so a reference angle is always positive. If we have a third quadrant angle, let's call this angle of rotation 225 degrees. So again, note that the x-axis is 180 degrees. We're past 180 degrees, so the reference angle is saying, how much past 180 degrees are you? Well, if this is 180 and we want to go 225 minus 180 is 45 degrees past the x-axis. Therefore, the reference angle for an angle of rotation of 225 degrees is 45 degrees. And a fourth quadrant angle, let's call this an angle of rotation of 330 degrees. Now, the second quadrant was using 180 degrees because that's the measure of the x-axis. The third quadrant was using 180 degrees because that's the measure of the x-axis. In this case, the measure of the x-axis that we'll be using is 360 degrees. So remember that a reference angle is a distance from the x. Very important. You're never using the y-axis. You're always using before the x-axis, after the x-axis, or before the x-axis. So you'll be either using 180 or 360 to calculate your reference angle. And in this case, since this line represents 360 degrees, if I were to continue around, that means I have 30 degrees remaining for my reference angle. Therefore, an angle of rotation of 330 degrees, which lies in the fourth quadrant, provides a reference angle of 30 degrees. So now let's see what these things are used for. Let's express the sine of 300 as a function of a positive acute angle. So now what this is asking you to do is asking you to change 300 to a reference angle and then calculate an equivalent function. The first thing we'll have to do is find the reference angle for 300 degrees. So let's plot that in standard position. If we have an angle of rotation of 300 degrees, the reference angle is asking you how far from the x-axis are you. Since this line represents 360 degrees, that means we have a 60-degree reference angle. So now I know that the sine of 300 is going to be the same thing as the sine of 60. That's what a reference angle is used for. However, if you plug these into your calculator, you're going to get a different value. Not by much, it's going to be off by a negative. And the reason for that is because of where trig functions are positive. The mnemonic device that we use to remember where trig functions are positive, all students take class. If you're going from quadrant 1 to quadrant 2, to quadrant 3, to quadrant 4. So now, since we're working in the third quadrant, the only function that will yield a positive value is cosine. We're working with sine. So the sine of 300 is going to give you a negative value. We need to account for that over here with our reference angle. So the way we do that, stick a negative in front. So if you calculate the sine of 300, that's the same thing as calculating the sine of 60 and making it negative. Now the sine of 60 was a special right triangle value. That's something we memorized. If you recall that the sine of 30 is a half, that gives you everything else. Since the sine of 30 is a half, the sine of 60 can't be a half. That means the sine of 60 is radical 3 over 2. So what we did, we calculated the sine of 300 by hand by converting it to a reference angle, calculating that reference angle's value, and then make it positive or negative depending on what quadrant we're in. Let's do it again. Let's calculate the exact value of the cosine of, let's do 210 degrees. So what we'll have to do is find the reference angle for 210. Let's plot the angle of rotation, and eventually you won't really necessarily have to plot the angle of rotation, but it's nice to visualize. 210 is in the third quadrant, so let's draw that as an angle of rotation. Theta equals 210. That means our reference angle, this is 180 degrees, this is 210 degrees, so we are 30 degrees past. So that means that the cosine of 210 is equal to the cosine of 30. Notice, I left myself a little room here just in case I have to make it negative. And I'll make it negative if we're in a quadrant which gives you a negative cosine value. Let's check. We know that all students take class. Since we're in the third quadrant, tangent is the only function that will yield a positive value. We're working with cosine. We're working in the third quadrant. Cosine in the third quadrant gives you a negative value. So we have to account for that by putting a negative in front. So now, cosine of 30 is a special right triangle value that we memorized. I know that the sine of 30 is a half. That means the cosine of 30 can't be a half, which means that the cosine of 30 is radical 3 over 2, and we had that negative sign in front. So we calculated the exact value of cosine of 210 by hand without the use of calculator, using a combination of reference angles and special right triangle values. Let's do one more. And let's calculate the exact value of tangent, and let's say in the third quadrant, let's say 240 degrees. So let's draw an angle of rotation in the third quadrant. Let's sketch an angle of rotation of 240 degrees. The x-axis is 180 degrees. We are 60 degrees past that. So our reference angle is 60 degrees, which tells me that the tangent of 240 is the same thing as the tangent of 60. And now I'll see if I have to make it positive or negative. We know that all students take class. We're in the third quadrant. Tangent yields a positive value in the third quadrant. Therefore, I do not have to make this negative because tangent is positive in the third quadrant. So I don't have to manipulate the sign. So now the tangent of 60 isn't something I memorized. I did memorize sines and cosines. So I'm going to express tan 60 as sine 60 over cosine 60. That equals. And now these are values that I memorized. And I'm going to express this as a fraction and then clean it up. Well, sine of 60, I didn't memorize that. I know that the sine of 30 is a half. Well, if the sine of 30 is a half, the sine of 60 can't be a half. The sine of 60 has to be radical 3 over 2. Well, if the sine of 60 is radical 3 over 2, the cosine of 60 can't be radical 3 over 2. It's got to be a half. And in this case, we have canceling 2's, and radical 3 over 1 is radical 3. So what we did, we found the exact value of the tangent of 240 by using a combination of reference angles and special right triangle values. So the combination of these two topics just helps you more readily calculate the special right triangle values around the angles of rotation. So now we're not restricted to 30, 60, and 45. Now we can calculate the exact value of any multiple of 30, any multiple of 45 between 0 and 360. Okay, just note here that exact means fraction. Do not express it as a decimal. Radical 3 over 2, if you put it into your calculator, is 0.866. That is not an exact value. That's a truncated value, not exact. Exact is radical 3 over 2, 1/2, radical 2 over 2, and numbers such as that.